Welcome to this explainer. Think of today's session as an ancient warrior's training ground. We are bringing the discipline of the last samurai to your exam preparation right now. It's ancient warrior wisdom meeting modern Cambridge exam strategy. You literally need to learn to slice through complex questions with absolute, undeniable precision. In this session, we're going to decode exactly what Cambridge examiners are actually looking for in Section 8.3, Data Definition Language, or DDL, and Data Manipulation Language, DML, specifically for database structure. We'll be looking really deeply at the Computer Science 9618 syllabus to help you secure those top-tier A-star marks. See, so many students walk into these exams armed with what is basically a wooden sword. You know what I mean? They have the basic knowledge, sure, but they lack the sharpness to actually cut through the examiner's specific requirements. Well, today, we forge the steel. We are going to completely transform how you approach your past papers from the ground up, making absolutely sure you never ever leave easy marks on the table again.
So let's just dive right into this critical question. What actually separates an A-star from a B in computer science? We're going to answer this by analyzing principal examiner reports and looking directly at how the top candidates actually structure their database problem solving. To really paint this picture for you, I want you to imagine two typical students. Let's call them Alex and Sam, and they are both staring down a massive, high-pressure 12-mark past paper question on database implementation. Now, Alex has an incredible memory, literally a sponge. So Alex overloads their answer with every single raw computer science fact they can possibly think of regarding SQL. They write down the syntax for create table, they list out all the data types. But here's the catch. There is absolutely zero analysis. They just dump facts onto the page hoping something sticks. On the other hand, we have Sam. Now, Sam understands the concepts really well but rushes. Sam completely misses the command word requirements. The question specifically asks to evaluate, but Sam just describes the database structure. Look at the contrast here on the screen. Alex's answer is just this massive wall of text with red pen marks circling the complete lack of context, and Sam's answer is literally crossed out because it didn't actually answer the prompt given. This right here, this is the battlefield. The gap between a B and an A-star is rarely about how many raw facts you know. It is entirely about your execution, your strategy, and your precision.
So, here is our playbook for today. We will systematically cover the foundational theory, the methodology for securing process marks, evaluating algorithm quality, and finally, the major pitfalls you need to avoid. We're moving way beyond rote memorization today and stepping directly into the mindset of a top-tier candidate.
Okay, let's dive into this first section covering the core principles of data definition language and data manipulation language, the theoretical architecture the whole assessment framework relies on. But hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's get back to the strategy.
Now, what's really fascinating about what you're seeing here is the stark contrast it presents. The examiners make it absolutely 100% clear that the academic benchmarks prioritize logical, analytical depth over just a superficial breadth of knowledge. If you look at the left side, superficial breadth is exactly Alex's approach from earlier. It's knowing the basic dictionary definitions of DDL commands like create, alter, and drop, or DML commands like insert, update, and delete. But look over at the right side. Analytical depth is what Cambridge is actually assessing. To achieve this depth, we use something called the PEEL framework. That's P-E-E-L, point, evidence, explanation, link. It's a real game changer. When an examiner asks you to justify a specific data structure for a relational database, your point simply states the chosen structure. Your evidence is the specific syntax or DDL command you would actually use to build it. Your explanation dives into exactly why the structure is optimal for the given data types. And finally, your link ties it directly back to the specific business scenario in the prompt. Integrating this PEEL framework is exactly how you move from the superficial left side of the screen to the analytical right side, capturing those elusive marks. To really stand out and capture the examiner's attention, your answers absolutely must demonstrate a conceptual understanding that connects DDL and DML with entirely other topics in the syllabus. Look at the characteristics here. Precise definitions means you actually know that DDL defines the schema itself, while DML manipulates the data within that existing schema. But the real magic, the A-star magic, happens at the third and fourth bullet points. Examiners for the 9618 syllabus, and honestly even the foundational syllabuses like 0471, 0478, 0983, 0984, and 2210, consistently and heavily reward students who show cross-topic connections. For instance, If you are writing a DDL statement to create a primary key, a top-performing answer doesn't just write the words primary key. No way. It establishes a clear causal relationship by explaining how that primary key ensures entity integrity, which then directly links back to the theoretical concepts of database normalization. You are basically showing the examiner that your knowledge isn't just kept in little boxes, it's a fully integrated breathing system. Let's transition right into section 2, the method mark strategy. This is where we take all that foundational theory and forge it into practical, point-scoring methodology. So the absolutely crucial takeaway here is that before you even begin writing your solution, seriously, before you write a single line of SQL on that exam paper, you must apply algorithmic thinking to break the database problem down. Let's bring our students Alex and Sam back into the picture for a second. To actually transform their grades, we need to rewrite their answers live right now. Imagine Alex is faced with a prompt asking to design and implement a database for a hospital. Instead of immediately writing create table statements wildly and hoping for the best, Alex needs to apply the definition you see on screen. First, decomposition, breaking a hospital down into logical entities like patients, doctors, and appointments. Second, data structure selection, actively choosing appropriate data types, like deciding to use an integer for a patient ID rather than a string to heavily optimize storage. Third, efficient code implementation. And finally, rigorous testing. When Alex actually slows down and applies this framework, you can literally see those red pen marks from earlier transforming into green check marks. What we are doing here is building the computer science success blueprint. And this beautifully illustrates the standardized, systematic sequence that practically guarantees you capture process marks, even if your final answer has a slight technical flaw. This is the ultimate method mark strategy. Let's say you're in the exam and you're writing a really complex DML query, maybe a tricky inner join between two large tables. Even if you completely mess up the exact syntax of the join condition in step 5, if you have clearly identified the key elements in step 1 and laid out your logical analysis cleanly in step 3, the examiner can still award you those precious method marks. They see the warrior's technique, even if the final strike missed the target by just a millimeter. Remember, your process is just as important as the final product in these advanced Cambridge papers. Now let's move right along to evaluating algorithm quality, which is where those higher-order assessment objectives really come into play. But before we launch into our interactive workshop, stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Doing them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Now, what's really interesting to note about this slide is that examiners expect you to explicitly identify time and space complexity to demonstrate true critical analysis. So let's kick off challenge 1, the data scan. When you are scanning a complex database schema, dealing with millions of records in an exam, you need to think critically about the core trend. As you scan, you absolutely shouldn't just be looking at the table names. You should be looking at the relationships and constantly thinking about the specific metrics on this slide. If you run a poorly optimized DML select query across a massive, completely unindexed table, the time complexity just skyrockets, right? The space complexity might also increase massively if your query generates huge temporary tables in the background. Evaluating this isn't just for standard coding questions. It applies directly to database structure. Top candidates will point out that defining an index using DDL drastically improves the time complexity of read operations, but it costs you space complexity. That is the exact level of depth required to get the A-star. Moving on, when you're asked to do a comparative analysis, you must use comparative connectives to highlight both similarities and differences before making any justified recommendation. This brings us perfectly to challenge 2, find the flaw. I want you to listen closely to this flawed sample paragraph from a mock exam. A flat file database stores data in one table. A relational database stores data in multiple tables. Therefore, a relational database is better because it is more complex. Okay, did you catch the flaw there? Take a quick second. All right, the sentence actively losing marks is that conclusion. It directly violates the recommendations row you see on our slide. Simply saying something is better because it is more complex is absolutely not justified reasoning. Using our Peel framework for our speed writing challenge, a perfectly corrected version would sound like this. A relational database is recommended over a flat file structure. That's your point.
By utilizing DDL to create primary and foreign keys, there's your evidence. We enforce referential integrity and eliminate data redundancy. That's the explanation. In the context of this banking system, this ensures that a customer's address is only updated in one place, preventing catastrophic transaction errors. And boom, there is your contextual link. Do you see the massive difference? That right there is how you secure top marks.
For our final section today, we are literally pulling back the curtain on the principal examiner reports to reveal exactly what goes wrong for the vast majority of students.
According to the data extracted directly from the Cambridge Principal Examiner reports, there are exactly 3 major mistakes that consistently, year after year, cost students easy marks in their exams. A top-tier student is already anticipating these 3 massive traps before they even finish reading the prompt. Let's uncover exactly what they are so you don't fall into them.
While ignoring boundary conditions and overflow is incredibly common, the absolute biggest pitfall is failing to adapt your knowledge to the specific scenario. Let's break these down specifically in a database context. Mistake number 1, forgetting overflow and edge cases. Imagine you use DDL to define a field as a standard integer, but the scenario system is meant to track global population statistics. You are going to experience a massive integer overflow. Mistake number 2, failing to test boundary conditions. If your DML query is supposed to retrieve records where a value is strictly greater than 10, did you test what happens when the value is exactly 10? These are the fundamental technical errors that just bleed marks. But listen, that final bullet point, that is the deadliest trap of all. You absolutely have to completely eliminate generic answers from your exam strategy and ensure every single data definition or manipulation is perfectly tailored to the prompt. Just look at the left side, generic answers. This is our friend Alex again, writing, "A database needs security." Look, it's a true statement, but it earns 0 marks because it means absolutely nothing in isolation. The right side, context-specific problem solving, is exactly what we want to see. If the question is about an online pharmacy, your answer needs to actually sound like it belongs in a pharmacy. To secure the online pharmacy database, DDL must be used to set precise user privileges, ensuring that while patients can execute select DML queries to view their own prescriptions, only verified pharmacists have the update privileges to modify dosage fields. Notice what happened there. You are using the exact same technical knowledge, but you are tightly wrapping it in the reality of the question.
This quote right here is the ultimate takeaway directly from the examiners themselves. If it's not linked to the scenario, it simply will not earn the mark. Period. So let's quickly recap the complete computer science answering system we've built up today. It really boils down to 3 golden rules that guarantee top marks. Rule 1, command word decoding. You must understand exactly what evaluate, describe, or implement actually means before you start writing. Rule 2, Peel framework application. Point, evidence, explanation, link. Never forget it. Rule 3, time management matrix. Please don't spend 20 minutes on a simple 4-mark DDL syntax question and then have to rush your 12-mark evaluation. Students who consistently implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're currently facing. Our team actively responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
So, as you continue your 96-18 exam preparations this week, I really want you to think about how you can practically transform your revision by implementing this precise, step-by-step examiner playbook. Are you going to keep swinging a wooden sword like Alex, just hoping raw facts will somehow save you? Or are you going to adopt the discipline of Sam's rewritten approach, actively analyzing those command words, carefully structuring your thoughts with the PL framework, and slicing through those database design challenges with absolute, undeniable precision? The choice is entirely yours, but the path to an A-star is now clearly laid out right in front of you. Take this strategy, go apply it to a past paper today, and witness the incredible transformation in your own mark schemes. Keep learning, keep analyzing, and I'll see you in the next explainer.